Hey everyone, and welcome back. Before we begin here today, please make sure that you like and subscribe because it really does help us out over here, and it also helps us reach others in need of assistance with these topics. So what we're going to be going over today is trigonometry, and we're going to be deriving the law of cosines. We're going to be showing where does this law come from. All right, so we're going to be utilizing this triangle here and just letting you know that we have three sides of capital A, capital B, and capital C. So everything that is capitalized will be a side. All their lowercase letters will be angles, and I will try to do my best to distinguish between lowercase c and uppercase c since they are almost identical. One's just bigger than the other. So, considering this triangle here, what we're going to do is we are going to divide the triangle, and we're going to split up side A into two right triangles. So what we're going to do is we're going to go right through angle A, and we're going to split side A into two portions here. And we're going to call this left side side D, and we're going to call this right side side E. So now A is split into D and E, and we have two right triangles going on right here. So applying the Pythagorean theorem to each of these right triangles, working with our left one here. So our left triangle, we would have D squared plus, if we call this height H, H squared is equal to our side C squared. Well, applying the Pythagorean theorem on the right side here as well, we would have E squared plus H squared is equal to B squared. Okay, well, rearrange both of these so that we have H squared is equal to, so rearrange them for H. So H squared is equal to C squared minus D squared. And this other one over here for the right triangle on the right side is H squared is equal to B squared minus E squared. Okay, so we can combine these two equations. So we would have C squared minus D squared is equal to B squared minus E squared. So that's our relationship between these two right triangles right now. So now let's keep this in mind. So keep this equation in mind. And let's do another step. So now we are going to write the cosine of angle C. So the cosine of angle C is equal to my adjacent over my hypotenuse, which the adjacent is E over my hypotenuse B. So let's rearrange this in terms of E. So rearranging this in terms of E, we get E is equal to B times the cosine of C. Okay, well, let's keep in mind from earlier right here that A is equal to D plus E. So let's rearrange this, and let's say that D is equal to A minus E. Well, what is E? Well, E is this. So we could write this as D is equal to A minus B cosine of C. Okay, so now let's bring this portion down here, and let's scroll up just a little bit here. So now let's bring this portion down, and let's write this portion in green. So we're going to combine this with our term of D. So we're going to take this, and we're going to throw it into D squared, and we're going to take this and plug it in here. So in doing so, we end up with C squared minus the D portion, which is A minus B cosine of C squared, is equal to B squared minus the E portion, which is just simply B cosine of C squared. Okay, so let's isolate C on one side by itself. And so that means taking this portion right here to the right side of the equation. So we end up with C squared is equal to A minus B cosine of C squared plus B squared minus B cosine of C squared. Okay, so we got to do some solving here and simplification here. So remember, or let's just write out this little portion right here. Let's say that we have A minus B cosine of C squared. Well, this is going to be equal to A squared minus 2AB cosine of C plus B cosine of C squared. Just solving out this first portion right here. So let's go ahead and take this and plug it in for our equation right here. So we have with C squared, all of this, A squared minus 2AB cosine of C plus B cosine of C squared plus the second and third portions here of B squared minus B cosine of C squared. Well, what we can do is, since we have plus B cosine of C squared and minus B cosine of C squared, those will cancel with each other. So essentially what we're left here is this. We would have C squared is equal to A squared plus B squared minus 2AB cosines of C. And this is one part of the law of cosines. The law of cosines has three portions to it, one for each side of the triangle. So we just did the C side. We would also have to do the A side and the B side. So if you were to repeat that same process, dividing it up, you would divide up each angle. So this one we did angle A, you would have to do angle B and angle C as well, and then repeat this entire process to get all of the law of cosine equations, because there are three of them. So if you repeat the process, we end up with our first one here. So then our second one would be B squared is equal to A squared plus C squared minus 2 times C times the cosine of B. And then our last one is A squared is equal to B squared plus C squared minus 2 times B times C times the cosine of A. All three of these parts form the law of cosines. And that's how you would derive the law of cosines using a triangle. So I hope this video was helpful. And if you want to see more problems of this variety, please check out other videos on our channel. Also, if you haven't done so already, please like this video, leave a positive comment below, and subscribe to the channel. Thank you for watching, and I hope you have a fantastic day.